In this video, we're going to look at finding missing angles of a right triangle. So it's going to take a little bit more work to find the angles in this case than it did in our last video because we had one of the angles already. I'm going to do number 5. And in number 5, we're missing angle Z, and we're also missing angle Y. So I can't really use the angle sum theorem to do this. I can't go 180 minus 90 and figure out what Y and Z are. I'm going to have to use soh-cah-toa. So I'm going to start this problem by writing down soh-cah-toa. That's going to help me figure out which ratio I want to use and what goes where. And then I need to pick whether I'm going to find angle Z or angle Y. And I think I'm going to find angle Z. So I'll have angle Z marked, and then I will label all of the sides as hypotenuse. So I know 18 is the hypotenuse because it's across from the right angle. Opposite, I know X is opposite because it's across from the angle that I've marked. And adjacent, I know 10 is adjacent because it's next to angle Z, but it's not the hypotenuse. And then I'm going to pick the two sides that have numbers. So that would be adjacent and hypotenuse. I can't use the opposite side in this case because then I would have two variables in my proportion, and I only want to have one variable when I'm done. So I'm going to use the adjacent and the hypotenuse because they both have numbers. Now I need to pick which trig ratio I'm going to use, and because I have marked up the adjacent and the hypotenuse, I'm going to use the cosine. So the cosine of angle Z is equal to the adjacent side, which is 10, over the hypotenuse, which is 18. And then I would normally go and cross multiply here, but my variable is in the argument of the cosine function. I want to find out what Z is. Z is that missing angle. So really what I'm going to be doing is the inverse cosine. I'm looking for the inverse or the arc cosine of 10 divided by 18. And I've got a couple ways I can do this. If I have a graphing calculator, I can hit the second cosine series of buttons, but I'm going to use the table of values that I have in my scientific calculator. Divided by 18 is 0.555 repeating. So I'm looking for the cosine, inverse cosine, 0.555 repeating. And this is a good method to use if you're just using a really simple calculator, maybe one on your phone, or you have just a 4-function calculator, or you don't even have a calculator and you're dividing 10 by 18 by hand. And then get your table. And I want to look in the cosine for 0.555 repeating. Look down that side, so I'm going to look down the second side. In between these two values here. So 56 degrees or 57 degrees. And I just need to make a decision, is it closer to 56 or closer to 57? But 0.555 repeating is probably closer to the 0.559 or 0.5592. So I'm going to say that the angle is 56 degrees approximately. So Z equals approximately 56 degrees. I'll go ahead and fill that in. And I could repeat this process, or I could simply use the triangle sum rule now, which is what I'm going to do, and go 180 degrees minus 90, that's the right angle, minus 56 degrees. And that'll give me Y. y is 34 degrees. So I'll add that to my picture. And then the only other missing piece of information is that x, the opposite side, if it had two sides of a right triangle, I could use Pythagorean theorem here. A squared plus b squared equals c squared. A will be x, b is 10, c is my hypotenuse, 18, and I just pop this right in the calculator. 18 squared minus 10 squared is going to be whatever x squared is. It's 100. 24 minus 100 is 224. And then I'm going to take the square root of 24. 14.966. And if I round up to the nearest 10th, or round to the nearest 10th, my 9 is going to round up to 10, which will make my answer 14. I'm not going to include the negative root here. I'm not going to write plus or minus. Sorry, 15. Plus or minus 15, because I'm talking about a measurable in 3D space triangle. So I don't have to worry about the negative root in this case.